In this case, we have a pilot flying along horizontally, altitude 2,200 feet, and maybe sees his house on the ground there. And so looking down, we use the phrase angle of depression. And remember that we looking straight ahead, in this case the pilot looking straight ahead horizontally, if they went up, it would be an angle of elevation. If they go down, like in this case, it would be an angle of depression. Okay, so and then what we're looking for is this distance from the pilot to the house horizontally. In other words, what is the distance horizontally or west to get to this house? So here we are. We are interested in using this triangle. It is a right triangle, so that's great. We can use their trig ratios. First step, can we figure out this angle here? We know that this is horizontal, this is vertical, so that means that's 90 degrees. 90 minus 45, we're left with 45 degrees in there. All right, so let's establish some sides. From our 45, our reference, across from that, opposite is our x. Beside that 45, here is our adjacent, and then the hypotenuse is always the one that is across from the 90 degree or the longest side, or in this case, our line of sight, the pilot's line of sight. So we have it set up, converted this from a real life situation into a mathematical model, and now it's time to solve. So we have our angle, we know our adjacent, we're solving for the opposite. Perfect means one unknown, and so what ratio uses the opposite and adjacent? Think about that for a moment and you should be coming up with tan. So tan of 45 is equal to opposite is our x, adjacent is our 2,200 feet, and we can stop there and we can say we want to solve for x. We're currently dividing by 2,200. So let's multiply by 2,200, and whatever we do to one side, we do to the other. And so these cancel out. We're left with x is equal to 2,200 tan 45. And we can pull out our calculator. And actually, before we pull out the calculator, do you have a guess? Could you do this in your head without a calculator? Give that a second. Well, 45, remember, it splits the 90 in two. And so we always know that if we have a triangle that's 90 here and 45 there and 45 there, well, that tells us that this side and this side must be the same. So that's a good little thing to keep in your head. Let's plug it into our calculator just to verify ourselves. 2,200 times tan 45 in degree mode, and you should come out with 2,200, and our units were feet, so our answer will be in feet. And yes, indeed, we should definitely stop and say if it's 45, then I would expect the adjacent and opposite side to be the same.